For question number 6b, there are kind of two ways to do this problem. And there are basically making the perpendicular line to make right triangles. So there's two ways to do this. One way is to draw a perpendicular line to that point and split it up into the triangles to the right and to the left. So this triangle here to the right and the triangle here to the left. So that would be one way to do it. Now there's a problem with the way if we do this. It's still solvable, but it creates a problem in that we split up the known side of 17 into an unknown part here and the remainder here, which we would call 17 minus x. So this becomes a bit of a problem that we introduce another variable other than our height. So the other way we can do this to avoid that is to drop our perpendicular down to on the outside of the triangle, and this creates two right triangles. One, this smaller right triangle here, and then we have a bigger right triangle on the outside, and we still have our perpendicular height that we're looking for, h here. Okay, so these are kind of two approaches that we can do, and we can use the big yellow right triangle first of all to solve for the length of h. So that's what we're going to do first. And so to set this up, we need to identify the sides we're going to use. So we're going to have our opposite side to 20 degrees and our hypotenuse. So we're going to set it up like this. The opposite side h over the hypotenuse 17. Opposite hypotenuse is going to be our sine ratio. And that's going to be sine of the 20 degrees that we have opposite. Okay, so then I'm going to do sine 20 degrees. Sorry, I've just got to get my into the right mode here. So sine 20 degrees. And we end up with 0.342. And that's all over 1. And then solving this ratio, we can solve this equation. H over 17 is equal to 0.342 over 1. And we can cross multiply this, and we get the height, in this case, is equal to 5.81. Okay, so we end up with this height value here of 5.81, and this then allows us to solve for the rest of this triangle. And in solving this, we're going to first of all find this angle here so that we can find the angle in the blue triangle. So that angle is going to be supplementary, so it's going to be 119 degrees, and the angle inside here becomes 61 degrees to give us 180 degrees that we want in that triangle. That 61 degrees then allows us to solve for this length here, I'm going to call x. Okay, and then we're also going to need to solve for this length y, and another length here z. And z is going to be the bottom length of that yellow, y plus z will be the bottom length of that yellow triangle, and z will be the length that we're looking for in the original triangle. Okay, so I'm going to set this up using the 61 degrees. I'm now going to use the opposite side to 61, which is 5.81. And I'm going to use the hypotenuse, which is x. So opposite in the hypotenuse is going to be the sine ratio. And the angle that I'm using is 61 degrees. And so again, I want to type that into my calculator. I'm going to have sine of 61 degrees Okay, so sine of 61 degrees is going to give me 0.875 8.46, so I'm going to round that to 875. And then solving for x, I'm just going to cross multiply this, so I end up with 5.81 divided by 0.875. So I'm going to multiply that, and I get an x length that works out to be 6.64. So this unknown length is 6.64, and I now need to solve for y plus z and y, and that allows me to then figure out the length of z. Okay, so I'm going to first start with solving for y. So I'm going to use that blue triangle again. I'm going to use the adjacent side y, and this time I'm going to use the opposite side, 5.81. Oops, sorry, that's not going to work. I need to use a ratio that will work. So opposite, 5.81 over y. That's going to give me my tangent ratio of 61 degrees. Okay, so again, I'm going to just cross multiply this. I could have used the cosine ratio here, since I do have adjacent and hypotenuse. But I'm just going to use the tan ratio in this case and cross multiply this. So I get 5.81 divided by tan of 61 degrees. And again, using my calculator, I'm going to calculate this. And that gives me y value of 3.220. So I'm just going to round that to 22. I need to keep track of that because I need to calculate my y plus z value, and maybe I'm just going to use a variable for that. I'm going to call that side A, and we're going to use A over the hypotenuse of 17. So I'm going to use a yellow triangle now. The whole length A, the adjacent side, divided by 17 is going to be equal to, adjacent is cosine, so cosine of 20 degrees. Okay, so then I'm going to find the cosine of 20 degrees. That ends up being 0.9396, so I'm going to round that to 40. And solving for A, I'm just going to cross multiply that. And that gives me a value of 15.97. Okay, so then using the length of A, I'm going to solve the Z length here, and the Z length is just going to be the difference between A and Y. So that will leave us with Z, so 15.97 minus 3.22, and that gives me a Z length of 12.75 approximately. Okay, so there we have the lengths I'm looking for. I'm looking for Z, I'm looking for the X value, the X length, and I also have the angle of 119 right there. Okay, so those are the unknown parts of that original triangle.